Everyone, so today our group will present about product recommendation.
What is product recommendation? Product recommendation is a part of an e-commerce personalization strategy where products are dynamically populated to a user on a web page, app, or email based on various data. It is also a filtering system where they can predict and seek what items the user likes to purchase. It may not be 100% accurate, but if it shows what you are interested in, then it is doing the job. Famous sites like eBay, Amazon, and Alibaba make use of this to better serve their customers. What is a dataset? A dataset is a collection of information that can be accessed and manipulated by a computer. We will be using online retail dataset as an example. There are various variables in a dataset such as invoice no, stock code, description, quantity, invoice date, unit price, customer ID, and country. This is the online retail dataset. We can use DFHead to find the top 5 orders and DFTail to find the bottom 5 orders. We use DFDescribe to show quantity, unit price, and customer ID in numerical, but there is an error here. What is it? The minimum cannot be minus. It happens because someone canceled their order, therefore the transaction has to be deleted. So now we will talk about canceling orders. There are two methods, but we are going to use this function. This function will filter the row to find the quantity that is less than 0, and you can see at the bottom that the total cancelled orders are 10,624 orders. This is the order method to find the cancelled orders. How to ignore the cancelled orders? So firstly, the amount of data with the cancelled order is 541,909. And you can enter either one of those two codes to ignore the cancelled orders. And when you see the number is different, then you have successfully ignored the cancelled orders.
So now we will continue to talk about data preparation. So how to count the missing values? So you can see from the dfShape function that it already changes to 531,285 rows, which is our new data set. When we use the df customer ID function, we can see that the customer ID value is only 397,924. So we can conclude that there are a total of 133,361 missing rows for customer ID. So how to exclude the missing values from the dataset? In a product recommendation, we cannot do a prediction with missing customer ID. So we have to exclude it using the drop NA function. So with this function, the missing value is excluded and it changes from 531,285 to 397,924 rows. Now we can set the customer ID as an integer using this function, and after that we can use df customer ID to show the data without any missing values. Now we will move on to advanced addition supplements. So currently there are 397,924 records and 8 fields. We can see that by using the dfShape function. To find out the field names, we can also use dfColumns function. This function on the screen right now can tell us the unique customer ID, but it is hard for us to count how many ID is available. But we can use the function len, which is length, which will tell us the total of unique customer ID. You can see here if you want to use the codes in different columns, it's very easy to change. Just change the name, for example, to stock code, invoice number, and country. Now we will continue on about days of trading. So here we use the code invoice date unique to find all the invoice dates, but as you can see, there are 3 on the same day. So it does not make it accurate. So 7,286 trades is not accurate. Now we can see here from the invoice date that it is very detailed from the year, month, day, hour, minutes until the second. And to separate those data to make it more clear, we can use these functions. We can also generate a new invoice date without the hour, minute, and seconds using this function. By using this function, we will generate a new column like the picture on the right. So by using both of these functions, we can see how many days in the correct transaction. To make the counting easier, we can use the same function as the last one, which is length and total transaction is 305 days. So why is data analysis important in e-commerce sales? Because it can help the company measure how successful their marketing and advertising are. They can also improve and make informed decisions based on the data analysis. The company will also know what is best for the customers as well.
Now we're going to talk about how to find the top and last 10 datas. Here we use the invoice number for an example. With these codes, we get the top 10 quantities in the invoice number group. Until this step, it's the same as how we find top 10. The only difference is the last step. You changed head into tail. So instead of finding top 10, it gives you last 10. Now we're going to talk about how to make different datas into a group. We use country as an example. After using these codes, the whole quantity data of country data set is stored in df country. If you want to do this with other data, just change country into the data you want. Now we are going to generate a new column. Total price, total QTY. And then we're going to talk about pivot table. With these codes, we can generate a pivot table. From this chart, we can see which customer bought which product. If the customer didn't buy the product, then it shows NaN on the chart. We can also see how much product the customer bought. Here we want to change NaN, which means the customer didn't buy the product, into 0, and if the customer bought the product, it shows 1 instead of the quantity. Because we don't care about how much the customer bought, we just want to know whether the customer bought the product or not. The result looks like this. All the NaN turns into 0. Next, we're going to talk about collaborative filtering. There are two types of collaborative filtering. One is user-user and the other is item-item. Next, I'm going to talk about the user-user filtering. It's when a customer buys a product, we see if there's other people similar to that customer. Then we recommend the product to the customer bought to the person who is considered similar to the customer. Because they're similar, the probability of the person buying the product is higher. Item-item filtering, on the other hand, is more straightforward. When a customer buys a product, we recommend similar products to the customer. For example, if a girl buys a lipstick, she might want to also buy other makeup products, so we recommend it to her.
We use cosine similarity because it is the most common method. Here we see three people with different opinions on whether they like the movie or not. The solution is simple. The third audience has two same opinions as the first audience. For example, it's half, it's 0.5. The third audience have one same opinion as the second audience. For example, 1 out of 4, which is 0.25. Therefore, the third audience and the first audience have similar opinions. So guess the third audience and the first audience like the fifth movie. Generating matrix. User-user similarity matrix. With this code, we can generate the user-user similarity matrix, which look like this. Now, we can see the similarity between every customer. Second one is item-item similarity matrix. With this code, we can generate the item-item similarity matrix. Now, we can see the similarity between items. Making recommendation. User-user. For example, we want to find out the other customer who are most similar to customer 12350 and sort the similarity from large to small with the other function. As we can see, customer 17935 is the most similar to customer 12350. We get the customer 12350 per case list through this code. So we get the customer 17935 per case list. Next, we take customer 17935 as the target, and the recommendation strategy is to promote the customer 17935, the products that customer 12350 has per case, but customer 17935 has not per case yet. And these are the product customer 12350 has per case, but customer 17935 has not per case yet. For the item, we get the top 10 similar items. Then we get the names of the product, so we can recommend the products.
Generally, there are many customers, members or potential customers, shopping online. If user-user collaborative filtering is used, the user-user similarity matrix will be very large, and the calculation will be very time-consuming. In this case, item-item collaborative filtering can be used to calculate faster. Conversely, if it is a content-based website, such as news and blogs, the user-user collaborative filtering method is suitable because the products are news or industry articles, and the articles are updated. That is, there are many products.